Hey, it's Obi-Wan Pez for n-Simplex Pachinko. Hey, Super Anarchy. Sorry about that. I was just checking to see if everything was actually working, which it apparently is. Although it doubled the audio because I had it open in another window also, so oh well. So yeah, I have no idea what I'm feeling like doing tonight, so I thought I'd put it to an audience vote or something. Um, I'm trying to avoid starting anything new, but you know, probably any of the stuff we've been doing over the past few weeks slash months slash years, especially if it gets it off our plate, I suppose. It's not to say that I am in any way in have the capability of finishing something, but you know, I'll throw it out there. So I don't know if you all have any ideas about things you might be interested in seeing. We do have our old Valheim server that we haven't been to in a while. We could attempt speedrunning Stray for the last achievement. I am not in a good place to get it done in 2 hours, but we could at least go for a couple runs and see what happens. We could do some more stuff in Elite. I'm mostly leaning toward either missions, potpourri, some BGS stuff to try to get our faction boosted, some power play stuff to get our power play faction boosted, or just, I don't think they're doing any community goals at the moment, so we could. I did get Skyrim working, so we could do that. Get more stuff done in Risk of Rain. 1, 2, or returns. Yeah. Let's take a look at the next Astroneer event, because that's also going on. No, not anything new. Not anything new. I looked over and I'm like, oh yeah, Starbound would be pretty good. No, stop that. I mean, I have finished Skyrim, but I've done one stream with this character and one stream with a differently modded character. And now that the new mods have been put into place, like, the old one would just be an exercise in futility, I think. I do have some spooky type stuff that is lined up for later on in this month, including even just like, you know, on odd days of the week or something like that. I finally did uninstall a few games that like we 100%ed, so I'm not going to be doing them anytime soon. I will continue to leave Outer Wilds on there, despite the fact that maybe I'm probably not going to be doing it on stream anymore, just because, like, if somebody came in, I would just be like, hey, tons of spoilers. We do need to get back into Hyperbolica eventually, and I need to finish Manifold Garden. Heaven's Vault, I need to finish Heaven's Vault, but we need to rearrange the save files. Alright, and we just started Against the Storm and Satisfactory, which we could, of course, go for either of those. Yeah. Or in my case, double, because... Oh, man. I did my Outer Wilds tour as my first stream here. So that was our first non-mathematical stream. So that's been 3 years. And then we did Echoes of the Eye. Yep. We did Echoes of the Eye when it first came out. I actually... Cool story. I hope nobody from my work is here. Yeah, I called in sick that day. So, and then it was pretty awesome because I ended up screwing something up real bad in it, and like I solved the initial puzzle of how to get to the area via trigonometry because I teach trig. And then I got to the door, and I was like, I can't figure out this door. Yeah, it was pretty bad. Then I went back to the main game, and I was like, let's see if there's another thing in the main game somewhere that would, like, help me out with this. No, there is not. Yeah, I also need to get BG3 to work again. I think it's having some Linux temper tantrums. And so I need to fix it. It's the same problem. No, I shouldn't say the same problem. I'm having an issue with that game in particular. And I think it's a Proton error. And then I'm having an issue with DaVinci Resolve, which everybody's like, you shouldn't be having a problem with DaVinci Resolve, and I'm like, I know. I followed the instructions of like this fix that a guy had, and it still did not work. So I need to like uninstall it, make sure everything is downloaded, and then follow his instructions to the letter. Do not deviate 1 iota, and try to make it work that way. Alright, so later on this month, we do have, put it here. We do have Slay the Princess. No Time to Explain. Keep It in Mind, and Voyager 19. So those are going to be a bit later this month. They do have some intense silver. No, that's fair. You get... Alright, 20s tonight. So, thank you very much for the make sure to actually get up and do some work. I guess technically I'm putting him back in the same place, so it's doing no work, right? You do what you can. Yep. So I was working this week at Eskrima, and we learned like multiple combinations. I won't actually do it, but nonetheless. So when you're doing two stick stuff, we started from this position instead of side guard. So if you're doing a side guard, it was like up, down, swap, and then tuck, and now you're in a another position to start from your left side. And then our instructor added in some I will get back to actually weightlifting here in a sec. Added some where you're basically taking swipes at people. Keep in mind, these are machetes. So you're going over like this, and then, let's see, you're starting from here, starting from both shoulders. So you cut at somebody twice, and then you go to the guard position here, and now you're ready to do this one, just the same as you did before. And then you start from this side, and instead of going down again, you come up from this side, and then, what was it? Oh, no, we just go up twice, and then you're back on the shoulder. And then you could start from the other side again. So, cut down on the left, and now you're in the right guard. And now you're back on to left guard, cut up on the right. So you're doing typically 45-degree angles coming across the body like that when you do it correctly, which I do not. But it is really badass. Like, I can't tell you how much I enjoy this, having done karate for almost 20 years and like never done weapons training at all. Like, this sort of stuff is just a lot of fun. And I had a guy in our organization who also did Eskrima wherever he was. I can't remember exactly where he lived for a while. It might have been Philippines, in which case he learned it like directly. But he may have also lived in Japan or Korea. Yeah. Yes, we also don't threaten people. We also don't carry around club weapons in jolly old England, because they turn not so jolly real quick. Do I have a black belt? No. So I actually have a first-degree brown belt in Tangsudo Karate, which is the same style that was popularized by Chuck Norris in the United States. It's been in Korea basically 100, 200 years. I don't remember the actual history of it, so I'll have to look that up later. But they also did... it's not a threat, it's a promise. Yep. What is it? They were also part of an organization that's called Muda Kwan. So... I also, again, don't remember the translations exactly. Or at all. Down to 15s. This is also something to do. So my spouse and I used to do a extreme workout back when we were actually fit. And it was that you would do like a whole bunch of exercises at the highest weight that you could possibly do it until your muscles literally failed. And then you would go and grab the next weight down and do that again until your muscles failed. And then you could keep going down if you needed to, but the idea was that you'd still get through eventually all, 20 to 40 reps or whatever it was you were doing. I think we got... No, the 20s were the biggest we had. But... yeah, it was a good time overall. Thank you, Silver. So I was actually working toward my black belt, but I was gonna need like 3 more years, and I don't have a whole lot of confidence when it comes to particularly karate. I just always like overthink things, and I'm getting better now with weapons training, quite frankly, because like you have to feel it. You just have to know where this thing is going, because if you end up coming across your body incorrectly and your wrist is at the wrong angle, you will smack yourself across the head. I did in fact hit myself upside the head once yesterday. I'm like, all right, well, I'm glad that's not metal. And it was this one, which is a 250 gram polycarbonate. The other sticks that we use are rattan. This one has a 500 gram ironwood, so it's pretty good. This one's also 2 inches shorter, so like on the other one, I actually choke up further on the smaller ones. You're not supposed to. You're supposed to be basically right to the end, and that way you can also use the butt end as a weapon if you needed to. But for the most part, you're supposed to be here so you can do whatever you need to. But yeah, ironwood is really heavy. I'm not actually sure that's ironwood now that I'm thinking about it. My instructor had I want to say it was a 200 to 250 gram stick that was like half that size. So I'm thinking his was more toward that end. This might have been. It might have been advertised as ironwood, not been at all. Yeah, it was like I just held it and like whipped it around a couple of times. We were you have to see it, right? This is a visual art here. This is not something I could just talk through. So when we're doing things with the stick, typically you're either coming from an open guard here or you're coming from a closed guard here. And if you are whipping this out at somebody, then obviously, you know, you're aiming for basically like here right at the temple, or potentially you're aiming for the other person's hand. So you whack their hand, and that gets them immediately to drop their weapon. But from here, there were like several things that we were doing. One of which was to do a fan block, where you go this way and block this here, and then whip it around the other way. Now you've blocked, like either blocked twice, or again you hit their stick, so now the stick is out of the way, or you hit their hand, or you use the motion to then whip down. You hit their stick or hit their machete and come right down it, and again smack the person on the hand, make them lose it, whatever it is that is going to be done. Yeah, this particular style of yup. And I mean, we were practicing with like 100 gram padded sticks that are full rattan, not polycarbonate or like rattan is a lot like bamboo, right? So it's not like just a bamboo stick. It's a little bit thinner and yet stronger. and more lightweight. But you get these things going, and like the thing that I was doing with the like 1-2 underneath block switch, all that stuff. Yeah, that particular combination, you tend to slap the other person's hand quite a bit, but if you've got, we had padded gloves on, and still like that little spot right here, right around the stick, typically the back of the thumb was where most of the stick ended up coming down on if you ended up having your partner come down the stick. So we all had nice little bruises right here for a couple of days. Good times. All right. So we've got a few different things we can do. I was talking with Henrik a bit earlier. I don't want to do anything new. So we could go either with Against the Storm or Satisfactory, which we started this last week. Or we could try to finish Manifold Garden. We got a few horror games that I'm going to do later this month. So we'll wait until we're closer to Halloween. We could do more Elite Dangerous, which probably will have its own Halloween event at some point soonish. But mostly in Elite right now, I'm doing Stellar Cartography with Super Chicken. We're doing Work for Zachary Hudson, which, quite frankly, we're maybe getting closer to the end of. I've got all of his stuff done, pretty much. We've got the Boot Brigade that we're working with for Commander Psyche, and we're trying to clean up a bunch of stuff there, or we could just run missions for whoever. Or we have Valheim, which I still have a server that I have not gotten very far with. I'm in the swamps, I think. Can't remember if I defeated Loader or not. Not Loader. What's his name? Either way, we're probably getting close to the mountains. Do Astroneer, which has, again, the new event has come up, so it would be a lot of like fixing. Prismatic Queen. Good evening and welcome. My name is Obi-Wan Pez. This is n-Simplex Pachinko. We do mathy stuff on Tuesdays and gamey stuff on Fridays and whatever we feel like in between. So feel free to grab a drink, put your feet up, what have you. Grab a tablet, work on some math. Not many people probably invite you to do that. And I need to close Stream Elements so that we don't end up getting doubled audio all the time. Ooh. Hopefully that will not suddenly go off. I say we got Risk of Rain 1, 2, and Returns. We could work on a bit Noita. Stray, I could work toward getting the 2-hour. Cowboy Bebop, I did not say Cowboy Bebop. Stray, I have not gotten the 2-hour speedrun achievement, so we can try to move toward that. And we've got Skyrim, had a new modded game that I started, and I think I've got it balanced, so it should not crash. Yes, Talos guide me. The Talos whose amulet does literally nothing. I mean, if you wanted further proof, right, that Talos technically is not a god. Hey, Zach. Yes, I have played the Talos Principle, number 1. I do want to finish that as well, come to think of it. I can't remember. Yeah, I wanted to finish that as well. I don't know that I have it on here right now that I'm thinking about it. Puzzle. Yeah, no, I don't have it installed right now, but something to think about. You know what, I'm going to link a couple of these. That'll work. Alright, so we're going to go for a 5-minute poll. Everybody can take a look and see if you're at all interested in voting on one of those things. I did not add extra votes for, at cost, sorry. And as I said, I've got other more horror-themed games that we can play at some point over the month. I just didn't want to start anything new for tonight, so. Yeah, Henrik, I ended up 100%ing Talos Principle when it first came out. And then I was off by a few achievements, I think, but like I did the good ending. So I had like all of the red blocks. All of them. There were a few other things that I definitely got all the way through. But we got the good ending, and then I tried to get the like mediocre ending as well. I never got the minimalist ending or the speedrunner ending. But it's not really me. I also did it originally on YouTube, so my n-Simplex Pachinko channel might be under Obi-Wan Pez, I don't remember. Does have a playlist for Talos Principle. I believe it was called "You're a Sick Bastard," because I was playing the Talos Principle during the pandemic. Which, if you know the story, might be a little tone deaf. But yeah, it was. Yep. So I did all the stars and all the reds. It was crazy. Like, I don't recommend it. But then I was trying to like get as many as I could for my stream run, and I got to the third you know, the medieval type world, and it got kind of rough, and I'm like, I don't remember how to do any of this stuff, and it just kind of crashed and burned at that point, because I wasn't gonna sit there for 20 minutes thinking while everybody else on stream's like, move that thing. All right, Caramel Trocui, hello. Good evening and welcome. My name is Obi-Wan Pez. This is n-Simplex Pachinko. We do mathy type stuff on Tuesdays, gamey type stuffs on Fridays, and whatever else we feel like any other time we feel like it. Welcome on in. Hope you enjoy your stay. We do have mathy type people all throughout our stream and all throughout our community. E to the 2i Pi, that's Zach, is one of our other math chads. We also have Dawn Does Math, who is currently playing DayZ. Penn Center, E.N. Stuckey, Danny Highway, and Dr. Gold at Actual Education. Sequel's even better? Oh man, that's awesome. I'm looking forward to doing it. I just need to get some of this stuff off my yeah. off this list. Right now my favorites are 34 games long, and those are the ones that I just play all the time or like really want to work at. Yes, so I am a math teacher, or rather I used to be, but I still do it here on Twitch. So that counts. I have been had been a math teacher at a community college in Maryland in the United States for about 15 years. Oh goodness. Alrighty, so are we doing Valheim or are we doing Satisfactory is the next question. I put them together for a reason, right? It's sort of similar games, but so anyway, yes. Caramel, if you have a particular question, you can either drop it into chat, or if you go to Penn Center's Discord channel, let me pop that up here. If you go to Penn Center's Discord channel, there is a section for Math Forum or Math Chat, and you can put it in either of those places, and one of us will pick it up. If you want to do it like, you know, now, then I can take a couple minute diversion. Oh, interesting. What is your current level of comfort/expertise? My advice for anybody, no matter what level you're in, is just get out and find some interesting problems and play. So the current awesome. You know what? I'm really glad to hear it. My ex gave me a book to read. And then we broke up, and I never gave it back to her because I just forgot. Is this hers? Yeah, it's hers. Zero, The Biography of a Dangerous Number by Charles Saif. Zif? Nope. The Biography of a Dangerous Idea. It is a great read, and I found it accessible at 16, having not been in calculus yet. It is a bit easier once you have been in calculus, but it also lists off like a whole bunch of just ideas about how zero ties into a lot of other ideas, and I'm also that guy who ended up getting Davasobel's Longitude, the true story of a lone genius who solved the greatest scientific problem of his time. Very long, descriptive title. And The Golden Ratio by Mario Livio, who is on Facebook. So you can actually, like, reach out to him and talk with him. He might actually be on X as well. Oh, damn it, I did it. I did it, guys. It's Twitter. Everybody knows it's Twitter. And then we have the Matt Parker collection, which includes Humble Pie, things to make and do in 4 dimensions, and these... I've got like 4 books that I still need to read. The Signal and the Noise by Nate Silver, good one, and Around the World in 80 Games by Marcus du Sautoy. So Marcus du Sautoy is also a particularly, I think, good mathematical communicator. He did a series on BBC that was called The Story of Maths. And I loved it. I actually made it the central theme of my... Yes! Yep, Ben Orlin. Okay. So if you're interested in 4th dimension stuff, there is Matt Parker's Things to Make and Do in 4 Dimensions. Here it is. No, Things to Make and Do in the 4th Dimension. So, here's that one. Your particular cover may vary depending on where you are in the world. I believe this is the U.S. cover. And also, one that I don't have, Marcus du Sautoy wrote a book called Symmetry, which discusses the nature of symmetry, the idea, and right? What's literally? Okay, that was weird. Yep, there we go. Journey into Patterns of Nature. I got this one from my library when I was back in the States. It's pretty brilliant, and it talks about the multi-dimensional nature of symmetry and how we can use like graph theory and cool other stuff like that in higher dimensions to be able to represent some of the cool things that come out of the idea of symmetry. But yeah, there's so much really cool stuff that's out there. And if you were at all interested in higher dimensional type stuff, then this is the right channel for you, for you. Because my name, right, the channel name, n-Simplex Pachinko, has to do with creating a simplex, triangle, tetrahedron, etc., in n dimensions, and then playing a game of pachinko with it, i.e. you drop balls through a little chute, and then it gets in 2 dimensions, it gets knocked through the pattern. How can you think in 4D if you or I mean, that's a good question. A lot of people have different kind of analogs to be able to do it, and there's only a few people who actually like possibly understand it. So here I have my thing on the left is a 3-dimensional representation of how you would have a 3D simplex or a 3-simplex. Here, this represents the trinomial distribution. So you could see up at the top left here, a plus b plus c all raised to the n. So we're taking 3 choices and then doing some sort of random draw on those 3 choices with a given probability, and that ends up getting us this trinomial distribution. If you 4D golf, yeah. Or 5D chess with time travel, that's an interesting one too. Yeah, so if you try and build out, like, from the 2-dimensional case at the top right, when n equals 2, we have the standard binomial distribution, and the numbers of paths that the balls could take to reach each of those locations is given by the number inside of it. In 3 dimensions, we have the item at the bottom underneath it, where it says n equals 3. It's a tetrahedron, but you have to squint a little bit. So the thing on the left is the topmost point where all of the balls would go through. That's like the first decision point, if you will. Then it bounces to one of the 3 directly underneath it, which are triangular. They make a triangle. They're all 1s. And then if you go down one more layer, you've got a triangle that is made of 1, 2, 1 on every side. So there is 1 possible way for each of the balls to get to the corners. There are 2 possible ways for all of the balls to get to the ones in the middle. Then it falls to the next layer, which I had to make over on the right rather than underneath it again, because otherwise it gets really messy. And here we see the 1, 3, 3, 1 along each of the sides and the 6 in the middle. And then it falls to the 4th layer, and this is where we get 1, 4, 6, 4, 1 around the outsides and 12s for the 3 in the middle. So it creates this really cool thing. And if you were to extend this into 4 dimensions, i.e. a plus b plus c plus d to the n, and try to make a distribution based on that, then your first layer would end up being a single tetrahedron. Sorry, 0th layer is a single point with a 1. The next one is going to be a tetrahedron made up of 4 points. They're all connected, and they're all 1s. The next one down is another tetrahedron, but with 1, 2, 1 along every side. And it's, again, 4 vertices, which have 1s in them, and then 2s in between all of those 1s. So I can like actually draw it out or something like that at some point, but it gets maybe a little involved. So this thing, right, that contains both the 1 and triangle with, tetrahedron with 4 1s, and then another tetrahedron with 1, 2, 1 along every edge, and then 1, 3, 3, 6 along every edge, and then there's inside stuff as well. Like, all of those make one shape. I mean, yeah, it all depends on what you're going for. And I mean, it's also like it's hard to explain this stuff. It doesn't matter what language it is, but we can try doing our best, and we'll try explaining some of it. Maybe we're going to France next month sometime, or end of the month. So that's because we're going from the first step, which is how many moves will it... No. How many different paths could we take to get to each of these individual points? So, alright guys, we're going to have to delay this for a minute. That's it, we're getting out the tablet. Okay, so if we go to Excalibur, we're not on Excalibur. Cool. Okay, so with us being on Excalibur, right, we're doing, there we go. So what we have is, if you just have a single point, right, we're doing no choices. So this is going to be like A plus B plus C plus D to the, in this case, we're doing 0. I don't know if you know the basic binomial distribution, the 1, 1, 1, 1, 2, 1. Typically, given credit is given to Blaise Pascal. This would be called Pascal's triangle. However, the original structure in number theory was created by Liu Hui in China, and he was able to determine that if you just wanted to make like a structure that ends up having these particular numbers in it, we're just making triangles and then adding the two numbers above it to get the number below it. He didn't really have a purpose for doing this. He just thought it was an interesting number problem. And, you know, you being 17, this is a good thing to, like, just kind of work on for fun. Just see what you can do with it. So this, it was discovered by... I always forget. I keep attributing it to Al-Jayani, and I think that's wrong. Muslim mathematician. Al-Karaji. There we go. I keep getting that. So Al-Karaji, who was around in about 1029, so you know, we're talking basically 1,000 years ago, discovered that when you took a binomial like this and you raise it to the nth power, then that creates the exact triangle that we had there. Yes. So, in 2 dimensions, we get this thing, right? So this is a 2-simplex, also known as a triangle, right? We get a 3-simplex if we do A plus B plus C to the n, which is going to look like we have 1, okay, so on our 0th choice, we're saying how many ways are there to pick, and that goes to this as well, right? So all of our simplex polynomial stuff. What we're doing here is we're saying that if we wanted to, for instance, pick a certain number of A's and B's in the binomial, this is the distribution we get, right? So this is our 1a squared 2ab 1b squared if we wanted to pick between the a's and the b's. How many ways can you get, right? How many different ways can you get a squared, ab, and b squared? Okay, that's 1 and 2 and 1. Okay, fair enough. Here, with our trinomial, we're doing the same thing. But now, the thing is that our Pascal triangle here is going to be expanded into 3 dimensions because now we have an A and a B and a C on every possible choice. You can look at this in terms of vectors. So, like, from our top point here, we have 3 different possible ways to go. From each of those, we also have 3 different possible ways to go. Right, so the number of choices keeps expanding and all that, but nonetheless, the distribution of how many balls, if there were dropped through like that structure that I showed you on the front there, with if you had all hexagonal prisms that are chutes that lead to the next level, then this is what we end up getting, and our distribution ends up being that if you make no choices, you have one possible way of doing that. You make no choice. If you make one choice, then there are 3 different possible ways to do that. Either you pick an A, or you pick a B, or you pick a C. There's no other way for them to get to those particular locations. It's just, it went from the top, it went to A to B to C. That's it. Then when we go to the next level with our 2, this now with a trinomial, right? Our corners still only have one way to get to each of them. They are staying along each of the edges as we go out. But when you start moving along the faces, this is where we end up getting, you just look at the front face, right? The front face is 1, 1, 1, 1 blank 1. That looks familiar, doesn't it? Right? It's 1, 2, 1. Because if you select only one face, then it's equivalent to just doing the Pascal's triangle again. You're only doing a binomial. You've only got 2 choices if you have now neglected everything behind it. So every face of this 3-simplex is Pascal's triangle. All right, and then again, same thing ends up happening as we go down further and further and further. We end up with 2s here, and then on the next one, we end up with 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. And again here, this is our 3rd choice. We're going to get each of the faces are going to be the same as Pascal's triangle, so 1, 3, 3, 1. And then 3, 3, 1 here, 3, 3, 1 here. Well, now we've got this extra one in the middle. What happens? Well, all of the balls could have dropped into any of the 2s from the one above it, and then each of those could drop into the center. So it's 2 of them could come here from here, 2 of them could come from here, and 2 of them could come from here. So that leaves a total of 6 possible ways to get to that center one. Right, so now if we move it up to 4 dimensions, this is where it gets really complicated. Our 0th choice is just the 1, same as it was before. Our first choice ends up being a tetrahedron where all of its vertices are 1s. right? We come from the top, and we can choose to go to A, B, C, or D. One of those four underneath it. If we go to the second layer, then we end up with something that looks like this. Again, it's a tetrahedron. And again, it's each of its faces follow the same Pascal's rule. So we get 1, 2, 1 on each of those. If you're wondering, hey, wait, you just said it follows Pascal's. This doesn't follow Pascal by itself. That's fair. Oops, that's a 2. Where it follows Pascal's triangle is 1, 1, 1, 1, 2, 1. So we're only taking one slice all the way through. And then 3 becomes an even larger tetrahedron, and after this one, there's now 1 in the middle. And then there's a tetrahedron in the middle, and then a bigger tetrahedron in the middle, and then a tetrahedron inside of that. So this is one of the things that you could do, is you can expand this even further and start looking at all sorts of patterns that exist here. My dean had been looking at, with his students, at this layer here. So you look behind the slice, so like you cut off, it's all triangles. You cut off the face that has the Pythagorean, no, not Pythagorean, has the Pascal triangle on it. You take that off. What's left underneath it? Now it's the stuff in this like salmony color. It's a 1, it's a 2, 2, it's a 3, 6, 3. Notice how similar those are to 1, 1, 1, 1, 2, 1. Right? They're quite wildly similar. So they're just, this ends up being scaled up from the stuff underneath it. And then if we cut that face off, right, what's underneath that? Well, that starts us off with a 1 here and a 3, 3 here. And then we move on again, and there's something underneath that. And then we move on even one further, and there's a 1 here. And then underneath that face, right, it's a 1 followed by a 4, 4, I think, followed by, and it keeps going on. So they're all multiples of the original Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, etc. Oh yeah, there's a good explanation for it. So, I don't know if I want to ruin it. I think you ought to start looking into it. And if you want, I can give you some hints, or sure, I guess I could tell you the answer eventually, but there's some just really cool stuff. Alright, and the other one that I was working on was, ads. looks like maybe some people are back. We're halfway through. So, 2 minutes. Oh yeah, this is research. And this is really kind of where, like, you'd want to start just being curious about stuff. So, yeah, it's 10:30 for me, so similar. There's one more. Hey, me, Machine Rex. Ten more seconds. Almost there. Okay, so there's this thing called the Collatz Conjecture. Pick any number you want. If it's odd, multiply it by 3 and add 1. If it's even, divide it by 2. Just keep repeating. And the conjecture was, hey, it seems that all of these numbers end up going to 1. Megomorph, yeah. Pascal's pyramid. I mean, I think it should be Liu Hui's pyramid, but alright, cool. Right, so I try to give credit where credit is due. Liu Hui was the first one to build out that triangle as a number theoretic type problem, where it's just, let's see what happens when we do this. We'll follow rules and see where it goes. It has no real connection with anything. It just was, here's a set of rules, let's follow them. Al-Karaji realized the connection between the binomial distribution and polynomials. Like taking polynomials and saying, oh, well, if you multiply x plus 1 to the 4th power, then our coefficients are going to be 1, 4, 6, 4, 1. And then all of them are going to be broken out. Again, a to the 4th, b to the 0. A to the 3rd, b to the 1st, etc. And it was Pascal who realized that this could be used for binomial probability distribution. So his particular area was a very niche corner of mathematics. It was not, in fact, the discovery of all of this stuff. So the Collatz conjecture, yeah, we have not discovered any number anywhere so far that does not reach 1. All right, so somebody has set a computer on it and said, like, go find some number out there such that this does not work. Or it reaches a loop. If it ends up reaching a loop, then it's created a loop. That's really cool. And it didn't reach 1. So my favorite thing to do with this was, if you end up trying this out, create a map. So I'm going to pick 20. Right? 20 is even, so that's 10. 10's even, so that's 5. 5 is odd, so that's going to be 16. Triple plus 1. 16 is even, so divide by 2, that's 8. And then we're going to get since this is a power of 2, it's just going to go straight down through here, right? 16, 8, 4, 2, 1. 1 is odd. Triple it and add 1. That gets us back to 4. This has created a loop. So 4, 2, 1, 4, 2, 1, 4, 2, 1, etc. Right? So now somebody else could pick a different number, 17, say. And then we say, okay, with 17, we're going to triple it. That's going to be 30, 51, plus 1 is 52. Divide by 2 is 26. Divide by 2 is 13. 13 tripled is 39, plus 1 is 40. Halved is 20. Hey, look at that. So our 40 goes over to the 20 like that. Yeah, so Caramel, I need to warn you, right? The Collatz conjecture is essentially... Hey, there's the question I wanted. Good job. Parfait. All right, and that's how I know you're going to do great. So yes, the question is, how do we build this backwards? And then from where do we build all of these things? Now, I actually do have somewhere a sheet of paper where I started writing down all of the connections that I had, which started from, again, 421, building all the way back out until I got to 1,000,000 on every single branch. This creates a giant tree. So I said, let's try to find every single number that we possibly can, just for fun. Now, other people have heard me say this before, but this is essentially my mandala. This is something that I just, color in for fun. You know what? I'm probably not going to find it in the next half hour or something like that. So we'll see if it's in either of these two notebooks, and if not, oh well. That's NCTM, so no. Right? No. And this one looks like scrap, so probably not. No. Yeah, it's in neither of these notebooks that are first things to hand. I could probably figure out where it went pretty soon, but... Yes, so if you can actually find a pattern on which you could find a number on this list that exists here and say, I know that if I wanted to work backwards, I could pick, let's say, 16. What would come to 16? Well, first of all, we've got the 5 there. But also, we could have had an even number, which then got divided by 2. So that would have been 32. Which would have come from, potentially, 64, which would have potentially come from 128, which would have potentially come from 256. So again, powers of 2 are super nice. Then we could also say, well, what about these other numbers over here, right? We could have had 80 come to 40, and then 160, and then 320. Like, those are all even numbers, so if they just divided by 2 the whole time, they would have made it down there. So I think you're probably going to notice a question right here to say, like, okay, where are we going to come up with these branches? Where do they branch? So, Megamorph. It's all good. Ban. No. So if you understand modulus notation, modulus mathematics, you're good to go. You can use that as a hint. If you don't understand modulus mathematics, awesome. Just ignore that. Or put it in a notebook somewhere and you'll figure it out someday. But yeah, so I made a, like I said, I took a notebook paper, everything. I took a, standard 8.5 by 11 sheet of paper from the United States because it's not A4. And then built out that tree in like every possible direction. And it got really big. Like I said, I worked out, okay, once I found a number, we're just going to keep doubling it until we go off to 1,000,000. And then it doesn't take that long, right? And then here we say, what does it branch? Does it branch? And then we find where those branches are. And we say, from those branches, those all multiply by 2 over and over and over again. And then where do those branch? Etc. You're just here for the quality company. So not quite. You're not going to ignore them. It's just that this... right? And this is going to continue off to infinity. All those powers of 2, the direct powers of 2, are going to be kind of like your spine. It's the central piece that just keeps running up the center of the paper. And then we get these branches. Or trunk, I suppose. If we want to go with the tree metaphor, right? Right? And then here... this is going to be a branch. Right. So that's also an interesting problem, Megamorph, is some of them don't work. It's pretty obvious why they don't work. But we can let that one sit for a minute. But yes, you're absolutely right. This is one of those problems that like everybody thinks they've got a solution to it somehow. And no. This is actually an exercise in patience. And like I said, for me it's a mandala. It's making something beautiful. I have no need to solve it. I don't care. I don't want to solve it. That's not the point. It's just pretty much exploring what kinds of patterns do I see here. Are there interesting things that happen? Are there a lot of runs where we get a lot of branching? Are there runs where we get no branching? Just looking at these things makes it interesting to me. What if you had a graph of the values? So it has also been done to look for a graph of number and number of steps to get back to 1. This has been done. It's really cool. If you figure it out just for yourself, again, know that this has already been done, but that is something that you can check and take a look at it and be like, oh, well, that's really interesting. Let me see if I have the same answer as this other person. Again, I would recommend you do it yourself and then maybe go and check it. See if you get the same picture. Yeah, so, obviously 1 is going to be 0 steps because it is that, but 2 is going to be 1 step, and 3 We don't have 3 here. So it's up there somewhere. Don't worry about it. No, 3 goes to 10. Right. So that would be 1, 2, 3, 4, 5, 6, 7. Right, and then 4 ends up being 2. And then 5 we've also got on here. That's 1, 2, 3, 4, 5. Oh, yeah, I mean, by all means, go for it. You could play around with it and do anything you want to try to find like some interesting thing. Anything that interests you with this, right? Just again, you can find an interesting pattern that no one else has found. I guarantee it. I don't know what it is. It's probably not going to be super easy, but you could go off and explore the wilderness out there and find something super interesting. Just again, think to yourself that, okay, probably somebody else has found this before me, and it's not going to be like a solution. It's just going to be something interesting and cool. But once you find that thing that's interesting and cool, like, you can talk about it. You can be like, hey, I found this thing. It's really cool. Slides from Terry Tout. Nice. Yeah, he's... I mean, in addition to being a good... like... everything, he's also a really good teacher. I watched video of one of the classes he taught, and like the kids in his class, he says something. I don't even remember what it was now, but he says something, and it's like hinting at something that's just beyond their reach, and they're like, no, and all of them start scrambling for paper to try and like work at something. Recurrence reasoning. Okay, so I think maybe you're talking about implicitly defined sequences. So something like a sub n is equal to a sub n minus 1. I mean, even just the Fibonacci sequence, right? Add the 2 previous numbers to get the next number? Maybe? Recurrence relation, or implicitly defined. Not really. Okay. That's fine. Anyway, this is the Fibonacci sequence, and there is no explicit form. A sub n is a function of n alone. Right, this is... What? That's false? What? Binet form... Oh, get out of here. Okay, yes, fine. You can use it doing phi divided by the square root of 5. It's a function of phi. All right. Fine. Gross. First C when n equals 0, then... Oh, yes, okay. Inductive reasoning. No. Nice combinatorial interpretation of it as the number of ways to write n as a sum of 1s and 2s. Yeah. The other one to do is recurring fractions. So phi, which is equal to 1 plus the square root of 5 over 2 is, oops, right. That's not technically phi, that's going to be 2 phi. Almost got away with it, if it weren't for you damn kids. Yeah, so phi is equal to this whole thing here. Wait, hang on, did I? No, it is, okay. It does have a divide by 2. Okay, never mind. Next question, is that really just messed up? No, okay, it is all divided by 2. Okay, we're good. We're good. Never mind. Yep. Yep, if you take consecutive numbers in the Fibonacci sequence, it's about the right proportion. Which is like a really weird coincidence. Naturally, it's going to get further and further off the higher you go, but let's be honest. Nobody's going to care that much. By the time you get to the... Oops. By the time you get to that particular, like, order of magnitude, right, your error is also growing. Yeah. Oh, I guess your percent error stays the same, right? Oh, no, there are two moving parts. Okay, never mind. Just ignore me. It's all good. You do anyway, but... so anyway, recurring fractions here. Phi is 1 over 1 plus 1 over 1 plus 1 over, and continue that forever. It's just like one of those really wild things that works. And you can vary all of these numbers here to change what you get down the line for any irrational number to end up getting a recurring fraction that has a particular pattern. Now, it may not be a nice pattern. It may end up being, yeah, you could do it with any number you want. If it's of finite length, i.e. it is a, if it is of finite length or it repeats, so the number is rational, then you don't need this recurring fraction thing, or it'll end up being finite, so of finite length. But yeah, sure. So again, it may not have a nice pattern to it. Like phi is all ones in those 1 plus terms underneath. So like any number you want, you can end up with you can end up doing this, and your A, B, C, D, E, etc. will have some sort of pattern to it. Again, it may not be a findable pattern. It may be too hard, like, to actually figure out. So here's the thing, Mean Machine Rex, is that this is infinitely long for any irrational number. For rational numbers, it will terminate. And because it's going to terminate, then it ends up that you could just back it up, roll it back up all the way through, ended up making it a single fraction. Right? Because I can multiply both top and bottom of these things by a certain number, which would then collapse the that particular denominator. And then we could roll it back up term by term by term. So if I wanted to do some ridiculous, like, here, let's do 3.71417963014179. So, what are we doing? 14179,630. So if I wanted to do that, right, now I may have to go get my calculator because, just cause. And I may regret actually doing this, but it's fine. So one of the things you could do is just take off any of the stuff you don't like the 3, and just be like 3 plus, and then work on the rest of it as a recurring fraction. Yeah, so we could just make it 3 plus, and then here, instead of doing ... we say that this is going to be, right, 1 over, right, to get a 0.7. Oops. There is probably an efficient way to do this, and I don't know it. Okay, 3 plus 1 over 1 plus 1 over 2 plus 1 over Yep. All right. Carol, have a good evening. We'll see you around, I'm sure. And again, if you have any other questions, there are many more math streamers. I suggest following all of us because we can do all sorts of cool stuff. Answer any questions you've got. And yeah, have a good time. Hang out. I did not want that number to get bigger. Somebody wanted to learn category theory. Yeah, sure. I don't know if I have any prerequisite experience, but sure, I could be interested. Depends on what kind of. I mean, if it's like 3 a.m. here, probably not. But you know, hey. Holonomy, yep. Well, that's frustrating. I forget how to do this, quite frankly. How to make it nice. Nope. makes it smaller. Yeah. Oh. Okay, so if we bump that up to 9, what does that do to our number? 1.16. All right. Not small enough, so back up 2 places and make that a bigger number. Too small. Cool. Rex, there's a real plane, a complex plane. Is there a pure imaginary plane? So, no, but there is a pure imaginary number line. Right, so the way that really works is we've got our real numbers here, we've got our imaginary numbers here, and then all of this stuff together makes up the complex. Right, when the real part of your complex number is 0. Yep. Don't know if you have a perspective that would be broadly appreciated. Okay. Proper plane? No. I mean, it's just a number line. You could, in theory, make a IR by IR plane. So, like, you could just make one. There's nothing stopping you. But I would argue that this simplifies to real by real. And if you wanted to, you could, like, you know, essentially factor out your I. It's not factoring, but like if you needed it for some reason, right? You could make one, but it's not going to be a true imaginary number plane in the same way that you don't have a true real plane. You have a real number line and an imaginary number line, which together can make a complex plane, or they can be paired with like kinds to make their own planes in R2. Something that I have been suggesting to my students for quite a long time is Welsh Labs came out with a series called Imaginary Numbers Are Real. And if you take a look at, like, this is a 10-part YouTube series. This is actually his personal website, but nonetheless, it's all linked. And he just came out with a book of this, so that's also linked somewhere on his website. Supposed to go through some complex stuff, differential equations and matrices. Yeah. So the differential equations and matrices part that involves complex numbers is stuff that we talked about toward the end of our differential equations class, which is really cool stuff, which for the most part we're talking like eigenvalues of plus or minus I, for example, are going to yield a solution of y equals c1. I know you're not going to understand this quite yet necessarily, but the it plus c2 e to the negative it, which then simplifies to y equals c1 star cosine of t plus c2 star sine of t. There's some just really cool stuff that goes into there. If you're a pure finitist, you can believe that real numbers are imaginary. Yeah. Yes, that is true. Of course, it was developed by René Descartes in order to discredit such imaginary numbers. It's just only that the name stuck, and much to his irritation. Yep. Okay, cool. So, the eigenvalues from differential equations end up and eigenvalues from linear algebra, right? They're all connected. They're the same thing, realistically. We ended up doing domain coloring. Yeah. If you end up doing stuff like, right, y1, y2 is equal to, and then have each of these be related to a x1 plus b x2 cx1 plus dx2, right? All of this stuff. Wait, hang on. There we go. Differential equations. Right, this ends up being that our y prime vector can be equal to ABCD times our x vector. Just x vector, right? Not prime. Yeah, just x vector. So if we want to solve the differential equation that involves this particular thing, then that's going to involve your eigenvalues, which find the steady state. Right, they find your steady state vectors, so along what particular direction are these going to point, and then the multiplier to tell you how big or how small that vector is, or if it's been flipped in the opposite direction. And syntax, if you check out my my series on differential equations, that's in our channel here, then you can find like a bunch of this stuff that'll help explain it from a slightly different perspective. My point was that I went first with first order systems, and then I went with second order DEs. It's my channel. So if you just go into click my name down there somewhere, and it should list out a whole bunch of videos. If you click on like playlist or group or something like that, yeah, the VODs. If you click on the it's not playlist. What was it called? I don't remember what this platform calls it. Collections, thank you. Yeah, that's the one. So if you click on collections, you should see differential equations in there. I believe it's called class time, differential equations. And it should be somewhere around, let's see, we got 20 videos. It should be around 8, give or take. So we only did partial differential equations for a couple of problems. We were looking particularly at exactness. And so we wanted to look at how a particular kind of differential equation ends up showing up in ordinary differential equations and can be, we can leverage some of our Calc 3 type stuff, the vector calculus, in order to solve that. The way that I did it, I find probably pretty easy compared to, say, the way that I was taught, which I did not teach. It's an option, but I don't like it. Before PDEs, yes. I think you have to. Partial differential equations is usually either a senior level math majors class or a math masters class. So you're not doing it before then. I think at my school it might have been only graduate level. I don't remember. It's been too long. I didn't care. I was math education. But yeah, I don't think it was on my list of possible electives. Pretty sure that I had 2 senior level math electives that I had to take or something like that. And I did linear algebra, senior level linear algebra. Yes, high school. No. Sorry, college. So bachelor's, senior level bachelor's in mathematics, in math. You're not going to be taking it if you're doing math education, typically, unless you're planning on going on to higher ed, which I was not at the time. I was thinking that I was going to be a high school math teacher for the next 40 years of my life. All right. Nice. That's pretty cool. Does the physics teacher also teach math classes? Or is he just like a supervisor for also the math department? Everything in a circled area just canceled out? Yeah. All right. I will continue to answer any math questions you want, but we're going to hop over to Satisfactory, I think, which was the voted on item for tonight. So let's see. We were doing... kill this music here. Let the game music come in. He's only taught you physics. Okay, gotcha. Which makes complete sense, yeah. Alright, window capture. I get the feeling